We're going to be looking at how power functions can be transformed by adding or subtracting or multiplying numbers to their parent function. And we're going to look at two specific parent functions, but this works for any power function. So we're going to start with the y equals x squared. And remember, that means because it's an even power that we can expect both ends to go up, and it goes through the origin there, or touches the origin. And for an x to the fifth, that means that it has origin symmetry and left side down, right side up, because there's a positive in front. So it roughly looks something like that. But I would encourage you to test it out on your calculator. So I'm going to plot y equals x squared and graph that one first. So that's kind of the image that I've got there. And then I'm going to go in and I'm going to turn that function off by turning its equals off, and then come down here to x to the fifth, hit the enter so that the equals is lit up, and graph that one. So you can see the left side is down, and then it kind of does a little dip there, and right side is up. Kind of roughly what I have there. So the question is, if I put a +3 outside the function, all right, outside my normal parent function. So my parent here was x squared, and then I added 3. My parent here was x to the fifth, and then I added 3. So if we take a look at the calculator on that one, and again, I'm just going to compare x squared, and I'll turn this one off, to x squared plus 3. So the first one that gets drawn in is going to be x squared. And notice it's touching the 0, 0 mark. And then when I did the +3, everything got shifted up 3 units. And we're going to see the same thing happens. We turn these off and do x to the fifth now, +3. So x to the fifth goes in first, but then when I do the +3 to it, everything gets sort of cut and pasted up 3 units. So how did it change? Well, we had a shift up 3 units. Or whatever that number was going to be. So if it had been +5, we'd be going up 5. If it had been +8, we'd be going up 8. So it stands to reason then, if I have a minus outside of the function, that's going to shift not up, but down that same number of units. So if I come back in here, do a little editing, and do a -7, for example. All right, so I'm going to do the x to the fifth first, and x to the fifth -7. So there goes my original power function. And then the other one definitely slipped down 7 units. And you can test out for x squared -7 as well. So that's going to be a shift down 7 units. So if it's add, we go up. And if it's subtracting outside the parent, we're going to go down that number of units. Notice this is different though. Now we are adding and subtracting again, but we're inside the parent. As here, we're outside the parent. The parent was x squared, the -7 outside. Here it's a square, but we're inside of that parent function. So if we add inside, let's see what happens here. And I'm going to need to switch up some equations. So let me change this one out, clear that one, and clear this one out. So now I'm going to put in parentheses x plus 1, quantity squared, and then do the same for to the fifth power. So x plus 1 raised to the fifth. This one's a little misleading. You're not going to go up or down because you have to be outside the function in order to go up or down. So I'm going to graph first. Let me turn off the fifths power and just do the squares for right now. So let's take a look. There goes the original. And then if you notice, the second one going in moved to the left 1 unit. All right, we can see the same thing for the x to the 5th as well. All right, so again, we're going +1. When I graph it, it was at 0, and then it gets shifted over to the left 1 unit. So again, if it had been +8 inside the parenthesis, we'd be shifting left 8 units. So a plus inside means we're going left. So with that same logic, if it's minus inside instead of left, we should be shifting right. So I'm going to go ahead and write that in here, but then we're going to check it. And this one's going to be 6 units because it's -6. So let's double check. Come in here. I'm going to turn the squares on. And I'm going to make that -6. And then just turn this one off for right now. So we're going to see our squared function again. And then -6. Yep, it sure did move over further into the first quadrant, 6 units. All right. The negative being multiplied by a negative either outside or inside the function is going to give me a flip around either the x-axis or the y-axis. So let's take a look first. We've got our normal functions, x squared, and I'm going to clear this one out, and I want to put the negative outside the function. So notice the only thing being squared here is the x, not the negative. All right, so raise that to the 2 power. And then let me clear that one out. So right now I'm just going to look at x squared and negative x squared. And notice what happens. There's x squared. And then we flipped right around the x-axis. So we had a flip, we'll call it, around x-axis. When I multiply by a negative outside the function, I can expect that flip around the x-axis. All right, so let's double check with the x to the 5th now. So I'm going to put negative x raised to the 5th power. All right, so let me clear this one out, turn this one on, turn that one off. So remember, it started low, went high, and if I flip it, it's going to start high, go low. So that was a flip around the x-axis, or they'll call it a reflection around the x-axis. All right. So if I put it inside parentheses, all right, so let's start with here. Let me turn this one off and turn this one back on. And so I'm going to insert a parenthesis. All right, so now the negative is inside the square function. So let's take a look at what's going to happen here. So there goes my original. And then it appears I don't see anything, but what I really am seeing is this function, the second one went in, and it's lying right on top of the original function. There was a flip or reflection about the y-axis. You just can't see it because it's sitting on top of each other. Now, if you happen to do this, I can make this one a little bit darker just by coming over here. So now if I graph it again, there's the original, and then there's the reflection about the y-axis. So we can either say flip or reflect around y-axis this time. the same is going to be true for the negative inside the function x to the fifth. If we put a number in front, all right, this is going to either be a stretch or a compression, depending on the number here. Whoops, didn't want to do that. So let's go back in here, and I'm going to put in the number 8, x squared. So let me delete that out. And then let's take a look at how that's going to differ from x squared. So there's my x squared. And then notice the 8 brought it in, but what we're really looking at is it's a vertical stretch. So it's like I took this outside one and I just pulled it up and stretched it. A vertical stretch by a factor of 8. I'm going to squeeze that in there by a factor of 8. And the same thing with x to the fifth. If you come in and take a look at that function, so I'm going to turn this one off, turn this one on, that one off, and I'm just going to put an 8 in front here. So 8x to the fifth, and I'm going to graph that one dark. Right, so x to the fifth, remember low side up, 8x to the fifth, kind of, again, took my outside function and just pulled it up, vertical stretch by a factor of 8. So if I put in a number bigger than 1, it's going to stretch it. If I put in a number between 0 and 1, like a fraction, so if I put in 1/3, so let's try this. If I put in, okay, so I'm going to have to use parentheses here. Do 1 divided by 3, and then do x squared. All right, so I want the original. I'm going to turn this one off, and that one off. All right, so the lighter colored one going in is going to be the original x squared. The one that's going to be a little bit darker is the 1/3, and we'll see what the difference is here. There's my original, and notice the darker one is pulled out, but rather than think of it as a pulling out, it's really getting pushed down. It's a vertical compression. By a factor of 1/3. Or whatever that fraction may be in front. Now, if there happens to be a negative along with the number, then it's going to compress and then flip it or reflect it about the x-axis. So if it's positive, it stays in the same direction. It's just going to be a vertical stretch or a vertical compression. If it happened to have been a negative 8x to the fifth or negative 8x squared, it would not only be a vertical stretch by a factor of 8, but the negative then would flip it around the x-axis. So we have an order to this. We look to see first if you shift it horizontally, left or right, by looking to see if it's inside, if you've got any kind of adding or subtracting inside the function. Stretch or compress, that's if I'm multiplying something right outside the function. Multiply by some number. Reflection, that's if I'm multiplying by a negative. And then the last thing we look at is, do you shift it up or down? That's outside the function, and that's what we were talking about here. Subtracting or adding outside the function is going to be a shift up or down. So that's our vertical shift.